today, like we said, we're going to try to go as quickly into the codes as possible, and then afterwards you get a bit of time to practice more on the side as well. So we want to look into some formulas and other things, which is the stuff that we've covered in previous sessions. And if you reviewed if you did a revision for because we've done the data types, we've looked at data types practically as well. Remember using looking at the time where we looked at some Arduino codes as well, which shows us the data types, and we also did the size of operator and other things to see how the data types look like. So using namespace std, and we have our main function, and in the main function, we want to look at various data types. Actually, let's have some global variables. So if I have shorts, S and int I, and again, I have long N, L. And I'm going to include float and double. So these are global variables because they're outside the main function, and every other function can really access them, right? So we want to go inside in the main function, we want to just assign these variables or define them completely. Yeah. So to define them, we just say S equals maybe 20, I equals 100, L equals 1000, F equals 250 point, I don't know, some decimals. And we're gonna get D equals some numbers. So afterwards, we want to print out the values of, each of these decimal data variables. So we want to print out the values of the variables, and I'm just going to fast track that session. So we have the variables printed out. So I run the code, and we have the short, actually, I don't like it displaying it this way. So we've got a short, we've got an integer, we've got a long number, we've got a floating number, and then we have the decimal number displaying in this order. I want to try something. I want to try to make use of a function that has its own data types of exactly the same names as these ones. So if I have function, call it function. Should I return something? Yeah, so let's return an integer. Nope, let's return nothing. So we've got my function. And in the function, we want to take something. Nope, we don't want to take any parameter, so we can have a void or leave it blank. So let's declare the function at the top here. And inside the function, I want to have exactly the same data types. And maybe I want to assign them as I go. Did you submit? Well done. Good idea, you took the best. Okay. So in here, I want to call out, I can print them out again inside this particular function. And we'll just do some slide modification. I don't know, I'll add maybe some number at the end of it just to show there are some different things going on. So we have some data types. We've got a function with the same data types or data types variables redefined in the my function in that particular function. And we call the function at some point, let's call it here, after we clearly show a difference between the two lines. So I have that, and I'm just going to do this and say calling function. And I'll end the line there. Then I can call the function here. Let's try it. If there are no errors and it doesn't scream at us, then let's see what issues.
Yes, and I
Yes,
can
yes.
hear it.
You can't hear.
It's the servers are broken.
Giving up on us. So we work with this. So what's happened is that we've got some local variables, global variables, which can be accessed by all other functions in the code. But we haven't really, we have redefined the same variables. Basically, we've defined variables with the same name, but those are local to this main function. I want to find out what happens if, let's say, I move this. We notice it's compiled correctly. If I try to declare a variable with the same name, so instead of having this in a function, if I move them up here, for example, into the main, it doesn't complain, okay? How about outside the main function? Run it again, then it complains. Why? My question is, why did it not complain in the first instance when we had the same variable names as the global variables inside the main function? It didn't complain. When we had them inside the main function, it didn't complain. But when we had it outside the main function, it complained. Is the question clear? What are your thoughts?
Can you repeat, sir?
Okay, so I'm just going to Control Z to see what we've done. If I get this right. Yeah, I'm going to undo to show you what we've done so far. So we've got this code here where we have variables SILFD, right? So we have a short integer, long, and then floating and double data type variables declared outside the main function, but we define them inside the main function. And on top of that, when we are done with our main function, we have also defined a function that has exactly with variables. At this point we are declaring, right? We are declaring and of course defining. And the new variables we are declaring has exactly the same name as the ones outside. So S is S, I is I, F is F, and D is D. Exactly the same names. When we run the code at this point, and then we call the function in the main function here, it compiled all right, and it produced the expected results. We didn't get any error. Is that okay up to this point?
Yes.
Okay. Now I want to move this particular definition. Not necessarily move. I want to copy it and say, what if inside my main function, because here we are just assigning, we are not defining. What if inside my main function, I also had a variable that has exactly the same, I declared a variable that has exactly the same name as S. So what you notice is that at the moment, S is defined 3 times. So outside the main function, inside the main function, and then inside the function as well. The function we declared or we defined. So S is defined 3 times. And when I run it, it still compiles. It didn't complain. Does it make sense now? I mean, I can copy, I can print out the value at this point. So I print out, we've have this, we've defined again, and then we print them out at this point. So we notice that it still printed out what we expected. And my question is, after this, if we try to create a variable that has exactly the same name as S, I, L, F, or D, but outside the main function in the same place that we defined the previous one, and we run it, now it gives me an error. Why does it give me an error this time? Why did it not give me an error before?
I think it's because I think it's because previously you had it simply initialized outside the functions, and you didn't have it defined outside the function. And the ones that are actually defined inside the functions are scoped to that particular function. But when you define it like outside, yeah.
The first part is because we've defined it when we did this one. So I'm just going to remove the definition for now. So we know the first part is not the case, right? I've removed the definition. I have both declarations, but your second part, can you go back to the second part? We had to do with scope.
I was going to say like it probably because you were like redefining it in that particular scope of the function, but looking at it now, I think it's because you have like two variables with the same name.
But your second part, you actually answered the question. So we have 2 variables with the same, we are defining 2 variables with the same name, just as we have done here, and just as we've done here. But here it didn't complain when we had a function, it didn't complain. And then this point inside the main function too, it didn't complain. But suddenly when we came here, it complained. And yes, it has to do with the scope, exactly what you were saying.
I have another question about functions.
Ask.
Can I go? In a language like PHP that runs from top to bottom, that seems to be how C++ also works. You have to define a particular function that you're calling at the top before actually like using it. But here you have the my function right after the main function, but it's called in the main function, which is before the my function was actually like defined.
Okay, because I think it's easier to see it in code. Yeah, much better actually. So we've got our big circle, right? And inside this big circle, we have, let's say we've got a square or rectangle, something. Rectangle. And from that rectangle, we've also got what? Our diamond. To eventually make sense. And we say that we have the ability to actually load the diamond from the square. Yeah? Oh, I like this. I should save this for myself in terms of the site. So here's the thing about scope, okay? So this particular diamond, even though it sits in a different place, which is, in our case, is our function, right? That's the main function we created, yeah? Ayodeji, I'll come back to your question, okay? So this is the function we created, and this is the main function. And saying the main function is the driver function. So it means that whatever is inside the main function, that's what's going to be run. And as long as we call our function inside the main function, it can be loaded onto it. Now, here's the thing. When we get to this point, which is like the whole scope of our code, outside the main functions, variables that we declared during the preprocessor directives, those are global variables. So we really want to understand the concept of global and local variables a bit more. So these global variables can be made reference to in, or they can be loaded at any point into all the functions in the code. So in this particular case, the global variables can be loaded into the main function. For example, the same way the global variables can be loaded into the function that we have declared as well. I know I should use different arrows, but it makes sense to us. So if we have something like, shouldn't do that. If we have something like X, we can call X from the main function. We can call X from any other function. Does it make sense so far? I'm just waiting for a yes before I can continue. People cannot hear me.
Yes.
Good. So what we have earlier, we had S here. Remember, S is just occupying memory, right? It's just a name we've given to some space in memory. So even though it's the name we've given to some space in memory, it needs to be a unique global variable name when we declare it. So when we have our integer S, and again, we call another integer S, because they are both occupying the same space or the same scope, as Ayo was saying earlier, the compiler gets confused and it says, I cannot have two variables of the same data type of the same name in the same name inside the same scope. But I can have S and I can have another S. As far as the C++ or the compiler is concerned, even though to us both S's look the same, this S is completely different from that S. The same way the int S we declared in this particular area, as long as we declare them inside the scope. So this S is different from that S, the same way this S is different from that S, even though I'm just sort of using the same pen for both of them, right? So in here, because this is different from that, and our S here, let's call it the main S, and let's call this the function S. The main S can only be accessed from the main function or functions that have been loaded onto this. So we can pass this S as a parameter to that. The same way this particular S can only be accessed within this scope. Does it make sense so far?
Sir, can you explain again? I didn't understand.
Okay, so we've got the global variable S. Does that make sense?
Yes, sir.
And that sits in the bigger circle. Everything else that sits within the big circle can make use of that global variable S, right? And these are functions or method within that big circle. And we have two functions here, which is the square, which is our main function, and then the diamond, which is our function that we created, the main function we created. That's okay. So it means even though this S can be accessed, this S can be accessed by the main function and can be accessed by the main function. When we declare, because we declared it outside those functions, it was safe to declare new variables with the same name inside those variables because they are only local to this variable. Anything that's defined within the main function can only be accessed through the main function. And any variable that is declared inside our function can only be accessed inside here. For now, let's accept it that way in a much simplified version. So within the same scope, which is our bigger circle, we cannot have a variable declared with the same name because it identifies them as exactly the same, and we'll get confused about, so which memory space are you referring to? Is it referring to this memory or that memory? So hence, the variables need to have unique names. So let's try something. If we go back to our compiler, for example, and then we get this to work by commenting out this block. So at the moment, all we've looked at is that we cannot have S and then short s and short s in the same scope. So the scope here means that they are both outside the main function, right? They are both declared as global variables. So I comment that one out, get it to run. I hope this one too has not given up on it. Good, get it to run. And I want to define short twice as well. But this time it's inside the main function. Again, it complains because why? We have the declaration. I mean, we can have S and assign it to something, but we have S declared twice or defined twice. Again, how does it know? Because it's within the same scope, it's only local to here, but it can't really tell the difference. The same way if we do it for the inside the function, so I'll get this to work first by deleting what we just added or commented it out. And I go inside the function and I declare short twice. Why do I keep doing that? And I run it, it complains. Does it make more sense now? I always asking, saying that pretty much you can have the whole function here in other programming languages in order for it to work. So I'm going to get rid of this particular line first, which is where we declare the function, and I will run it. You notice that when I declared it, I didn't, because I didn't declare the function, it's complaining about line 47, which is where we call the function. Yes. Because at this point, it doesn't know what the function is yet. I'm going to try something different as well, something slightly different. So I'll cut the function from here. Let me get rid of it. And then I'll paste it before the main function. So this time I've pasted the whole code of the function, yeah? So if we go to the bottom, there's no function declaration after, definition after the main function. So I run it. It didn't complain. Yeah?
Oh, okay. So we can just do it like that instead.
You can, but it doesn't. Well, most programmers don't like this style because normally you can have so many functions in your work and you're going to read so many functions before you bother about what the main function does. So most programmers will prefer this approach. As far as C++ is concerned, as long as you declare the function before defining it. So in our case, we declare it first. So when it gets here, when the compiler gets here, it knows that it might be loading some functions, you know what I mean? So it reserves some form of, get the idea that we're going to use this function from a certain memory location. And when it encounters this particular line of code, it can load the function into memory. So the key part or the trick here is that we need to declare it. If we do not declare it, we're going to get an error. So imagine if we have several functions or 10 functions, for example, and that's the bit I was using to respond to you. Let's say we've got so many of these functions. It looks a lot simple to know that, okay, I'm going to use function S, function A, function this, then I can read my main function. And when I get to maybe line 47, previous line 47, I can say, okay, this is what that function does, that's what that function does. So it looks a lot cleaner, yeah?
Yes.
Good. Thanks for your question. If people are, since this is mostly variable declaration and other things, if people are happy for me to move on, I will be happy to move on as well to other sessions. Are you okay if I move on, or you want to try out the code?
So, but
Somebody
we need
talk.
the code just for like, give us like code and then we can try.
Okay. So does this have a save option? Okay, I'm going to do this. I'll copy this code and I'll put on a Word document. As long as you understand what I have here, I can save it and send it to you closer to the end of the class. Is that okay?
Yeah.
Yeah. And the more tricky ones, maybe we try together.
Okay, sir.
Thank you. You guys are awesome. Week 8. Today is Thursday. Thursday code. All right. So we want to look at one more thing with functions. We're just going to jump up back to functions, then we jump back again to look more about numbers and other things. And it's going to be really quick and things we can play with really quickly. And then we can go a bit more into details about some things as well. Nice and easy. So at this point, I'm going to do what I did. Let's start from this code, right? Okay. I'm going to clean up the code a little bit because I think we call in so many things that we do not necessarily need. So I'm going to clean up this to make it smaller so we can see the screen. Oh. So get rid of that, bring it up a bit, and we want to return some values. No, let's take some parameters, right? So we take short as parameters, so short S, short Y. But because it's a function, it's not going to complain for us. And when we call it, we want to, no, short and long. Let's take the long L. Long L, it doesn't have to be the same name because we are giving it new names as well, and we pass into functions anyway. And in here, we're going to pass, where do we call the function? Did I delete it? Okay, we've got my function there. Okay, that's where we have it. So we're going to pass S and long to it. And in here, when we have the definition, we're going to have short and then also short S and then long L. And inside, maybe we don't want to do all this again. We simply want to print out short short is equal to S and maybe and long is equal to L. Then we can end line if we want. So let's run, make sure it doesn't scream at us. Good, it's not screaming. So basically it's taking the short and then it's taking the long and assign it for us, yeah? Yes?
Yes, sir.
Good.
Yes, sir.
And if I run through the code, let me see. Let's clean up this because it's not as nice as the previous code. It's just like the same code. I'm just making it short. I'm going to move the function up so we can print out. Let me put this here. Bit of house cleaning, and then also exiting function there. And I can call the function up here. After these assignments, make sure it doesn't scream at me. It did. What did I miss? Something end line. Oh, where did it come from? And I've lost my cursor. Somewhere there.
It's 2 time and L on
Yeah,
30.
I've got it, but I lost my cursor completely, so I couldn't see what I was controlling. But we back up. We back up. We back. Thanks. Who was that? Was that Inshal?
Right.
Raj, I like the fact that you are very much awake and with me. That makes me really happy. Oh, what else did I miss? Did somebody see something I missed?
Yeah. You have to put like the, what
Oh
is
yeah,
it called?
that's where the end line went.
Yeah, and,
Effect of copy and paste.
both like last also, at the end also.
Sorry?
Near exiting function. The same thing at the last.
Yeah.
Yeah.
Same mistake twice, isn't it?
So, do we need to return at the end or not?
Yeah,
No.
exiting function.
Okay.
Because this is a void function. So we're not returning any value. Yeah. I know the last time during class when I was explaining and I actually got to the return, I said we don't need a return over there. But I know that I left it there so at least people know it can be done even for void, but it returned nothing. Yeah, we've got our function working, and we're thinking, okay, so if we do this, so this function is supposed to take a short and a long, right? And then we notice that the order also matters. So we have to, if whatever goes into the first has to be the short data type and whatever goes into the second has to be the long data type, because that's how we have declared them. All right, so that's important. And it seems to work because we passed 20 and then we've passed the long value to it and printed them out. All right. What happens if I forget to include the L, for example? Yeah. So if I do that and I run it, it complains. What happens if, let's say, I think, oh, that's not the case. Let me have a comma. It still complains to me, because why? It doesn't know the value it should use for what? L. Does that make sense? In terms of the long data type, it doesn't know what to put there. So there is a way that we can actually have some default parameters. These default parameters are like the default values it will get if nothing is assigned to it. So let's assign something during the declaration. So we can actually assign, let's say, 200,000 to it, and then we run it. Okay, so 200,000 did not appear when we printed it out, right? It overwrote this. So it took the 1,000, is it 1,000 or 10,000 or 100,000? It's 100,000, right? And this is 20,000. So let me make it easy for myself. 100,000 and 200,000. So when we run it, what is happening here? When it gets to this particular point, line 24, it will take the 100,000, pass it on, and then it will overwrite this value, and that will be printed. So now, what if I forgot to add the L, for example? Is that the right syntax? If not, it will complain for me. Okay, so it complains because it's expecting something. But what if I get rid of the comma altogether and then run it again? It complains, it's expecting something. Something is wrong, something is missing. Why? Shall we assign a value here as well in the declaration, main function long? This is where probably the Python gains an advantage, but let's see. Oh, did I delete? Where did it go to? Oh, at the bottom. Clean up a bit more. Just bear with me whilst I do this anyway. And I can delete this. Did I save this code? Yes, I did. That's what we wanted. So at the moment, we are matching the declaration with what? The definition. That's what we're doing at this point, right? And then we want to try it out to see what happens, if anything happens in this particular case. Let's run and see. We may need the comma back. Oh, I keep losing my mouse. Right, it complains again. Why saying so what? The parameters of void, blah, 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 long mix, or default argument given for parameter void. Previously specified in void function. I want to get this right and sort it out without any issue. Run it. Okay. Now, at the moment, yes, we declare it once and we just make use of it. We don't have to match it. We get a syntax right. We can. I'll just give you another code that gives you furthermore. So we can either do this or back to what I'll come back to this, but back to what Ayo asked. I hope you don't mind if I call you Ayo, right? Where we put the whole code at the front there, and then we can have it equal to 200,000 at this point. And when we run it, more zeros in my 200, it doesn't complain. So we've got two versions that we know the function doesn't complain, and one of them was having this the definition there, but we give the default values. What are these default values? We will identify from here. At this point, we gave it the value s. We gave s, which is what, 20. We passed it to the function, and then it printed out the 20 for us. But at this point, we forgot, and we didn't. Well, forgot. We intentionally didn't add the value for L, or the long value, and it made use of this particular default parameter and what printed out the 200 there for us. So that's where it took it from there. Don't get distracted by this. That's the ones we are printing from there. Does it make sense so far?
Yeah, Professor, I have a question.
Please ask.
So why are we using the namespace standard library twice?
Are we using, oh, that's typo, isn't it?
Okay.
Yeah.
Oh, it's
Thank
not
you.
intentional. Okay, got it.
Yeah. No, it's not intentional. It's too many namespaces.
It's,
Yeah, it runs without it, isn't it? Yeah. I don't know, people may like this compiler, so I kind of like the other compiler because I know it works with files, but this one also seems to save the outputs directly on your temporary folder of your computer. So anyway, people can pick and mix, right? Okay, so does it make sense with the default parameters so far?
Yes, sir.
Okay, good. So if I try to give another default value for the short, I can go in there and then do something like this, 50. Again, because I've provided the value for the S, I can just come back to the L before we run the 50 and the 200. If I run it again, we notice that it's overwritten with the new value we passed, which was S is 20, L is what, 100,000, or some value that I can, it's 100,000. I can't really see, I've got it so far away. Right, now what if we get rid of, we forgot to include the S, or we don't forget, we intentionally do not include value for S, and the run of what did I do? Oh, I
Comma.
expect the primary token. It's the comma, but it's still going to pick the long. It wouldn't like it. There's something that's not right. I will have to fix it as we run away. I'll fix it in a different way because it's going to identify that as a long because that's the first space it has. Why is it not liking it? So what have I done different? Or what have I done? Not done right. Let me see the complaint it says. Expected a primary token. Leave that with me because I have to get that multiple thing right. We will sort it out before we leave this session today, okay? But at the moment, because I am expecting a value here. Let's stick with the S. I will save this code and I'll share a separate code and we'll work from there. Something I'm missing. Destin, is that you? Because I can hear the birds. Was that Destin?
I don't know what happened.
So who was that? Who had lovely birds in the background? So I've saved this code as well, and let's walk through some sample codes I really like, which is the one that we were using. So I wouldn't say I really like. Again, IO stream this that we've got sum of A and B, and in here we've got A having a or B having default value of 20, and then having your well, in here we're just using the previous or the other function definition type where we give the full definition of the function prior to the main function, and we have the results and we are returning the result value, just simply a sum, right? And if we have, let's say, A and then B, and then we call the sum function here, and we pass the value of A and B to it, and then of course we find that will give us the results, and we can have the results of A similar to what we have done. And like I said, I'll sort out the other version as well for you. So let me run it. Does the code make sense, or I sort of rush through it and you want me to break it down? I think it's quite similar to the code we just ran through. Does the code make sense, or you want me to break it down? Are we okay to go ahead?
Break it down, please.
All right, so we understand up to this point where we have, well, previous stuff, IO stream and then namespace, right?
Yes.
Okay.
Yes.
So if we include a function and it's called a function, it's called sum. So this bit is a function. I mean, I can move it down like we did before. So the sum takes two parameters, right? It takes two parameters, which is you've got the argument of variable A, and then you've got the argument variable B. Yeah. And when we give the B a default value of 20, because at the moment, what that means is that if B's value is provided, that will overwrite the value here. So when we call it and we put a value 100, that will overwrite, it will replace the B, which is 20, with 100. If we do not provide the value, then it will simply put what? The 20. So what does this function do? Inside the function, we declare local variable called results, and then the results will be equal to the sum of A and then B. Does it make sense so far?
Yes.
Okay. Then we return the results. And you notice that this results is an integer, and because the results is an integer, the return data type of the function is what? Int. So we come into our main function. So inside the main function, we've got some local variables which are integers, A, which is 100, B, which is 200. And then where we started from, we have the main function has its own results as well, which is different from the results declared inside the function sum because they have different scope, okay? So the results inside the main function will we call the function sum. That will return the results value, but we pass the results value to a variable called results, right? So basically, that's why the assignment statement there, because we are returning something, we are returning an integer. So we take A, which is 100, and then B, which is 200, and pass it to that. So 100 plus 200 will run for the first instance. So in the first one, 100 plus 200 is 300. Then the second time, we call the sum function again on line 19. When we call the sum function again, this time we did not provide the B value. So we only provided the A value. So if A value is provided, which in this case is 100, and the B value, it would take the default value because it's not been assigned yet, right? We didn't assign it here. So replace the B with 20. So 100 plus 20 is equal to what? 120. Does it make more sense now?
Yeah, thank you.
Thank you very much. So I'm going to pass this code to you in the chat window and I'll let you sort it out. I'll let you try it. And whilst you do so, I'll sort out some of the things that did not work on this side. So the code is in the chat window for you, and I'll pause the recording now. Make sure you understand though. And I'll say I was working on a code. It may or may not compile, but let's see. Yep, it compiles. So this is the code we were working on just before the one I copied across for you to work on, because we were trying to figure out why there were some issues with things like the default parameter for the first bits and all those kind of things. But it's quite an interesting thing to see and to play with. So what I have done is, I think we will make some really good observations here. I really like what it is really. Let's do this. Let's move the function to the top. So we do it before the declarations. Yeah, and we run it here. So it's working at the moment. It's saying that what? S is 0. I'm not sure whether you can actually see it. It's saying S is 0. Let me move this away from that last line because that doesn't make sense. And then I'll move the float. I've made it 3 parameters. I'll tell you about it in a second. So before we had the short and then we had the long, I've added the float to it. So if I go into the definition, I print out the short and I print out the long, then I print out the float. That's all we're doing at the particular moment. So if I run it, we notice that S is 0, but the long has taken the default parameter and the float has taken the default parameter, right? So if we come up, the default parameter we put for the S was 50, but we printed out 0. And then for the long, okay, that worked. The float, okay, that worked. Can we also, if we go to the line, I think, which line, it's line 7 now. So if in here we add, let's say, the long value, let's put some actual number here, because, so let's say we pass 5,000 to the long, and then we leave the other one. I'm not sure it's going to complain about comma. It will complain about comma because it doesn't like comma. We leave the last bit, for example. Okay, this time it's taking the 5,000, but the long is still what? 0. And then it's overwritten that and it's kept the default value for the float. So what if, let's say I put the comma in between and then this sum points on there? Doesn't work. What is happening? it's a bit interesting, right? So let's say you can do typecasting if we want. Let me run it again. Yeah, here's the interesting part. C++ completely ignores the assignment of the first parameter. Does it make sense? In terms of the default value. So when we do it, it doesn't allow us to write in a format where we use comma separation, for example, and it doesn't really like assignment of default parameter to the first element, but it allows us to do so for the second element and so on, right? So that's something that, I mean, of course, I had to investigate to ensure that it's the case and have found out. So it's something that I would say is worth noting as well, as long as you understand the concept of the default parameters. And it's worth noting that even though you may have, if you want to use default parameters, of course, it makes more sense to not have any for the first element, and then the other elements will have the default parameters as well, and you can actually get rid and pass them on. Does that make sense?
Yes.
Brilliant. So do I copy this code? I will save this code anyway. And then I'll save all of them into one Word document. So it's a lot easier to share with you. Just that it wouldn't be as beautiful as it would be if, let's say, I share them separately. I'm just going to use space to separate the codes. We did say, are you happy for me to continue? We finished a bit early. I think we've got like 30 minutes or something, but we finished a bit early, okay?
Yes.
Okay. So I'm going to walk through some codes just because I think, whoa, they are there. You need them for your revision. But also, I kind of think we've gone through them already, but I'll be sharing the codes with you soon. So let's walk through some codes. If they don't make sense, then I'm here to explain them. But these are codes you encounter in your stuff. I hope this one likes functions, allow us to use functions. Otherwise, we have to go, oh, yes, it worked. I was a bit worried that it wouldn't work with some functions or headers that we include. Right, so you've got a lot of explanation on there, which is pretty much the notes that you will get from the PDF. And if I walk through the stuff, we have the IO stream, which you're already familiar with. Remember, we had to include the string header for the string function to in order to use the string data type. Yeah?
Yes.
Good. So the same way we have the C math library, or it's simply a math library that allow us to make use of some standard math functions. These are written for us already, optimized. We just need to be aware that we have access to these functions we can use in our code. So it helps us to write really complex stuff that will also make our code do really, really powerful things. Let's put it that way. So that's what the CMAT function gives us. And of course, you're more than welcome to even search for it into details in terms of functions that it can provide for you. I can give you a link if you want. But again, we meet namespace just because we're going to copy out some things or print out some things to the screen. Variables we have met. So here comes our friends again. So with the short, the integer, the long, and then the float data types, as well as double data types. But these, because of the CMAT library we have used, we can make use of the sign of a data type, which is sign, absolute value. So absolute value, what is absolute value of -1?
1.
Good. Absolute value simply means that you are looking at the value itself, not looking at positive, negative sign, and they are all positive anyway. So absolute value of -1 is 1. So -1,000 returned 1,000, which means it's working. Like the floor, you can get more definition in here. So you've got the floor on there, and then the floor of which particular data. The data was 230, was D. 200.37 whatever, and of course it returned the whole number as expected. So it has returned the whole number for us. And also the square root of a number. So let's find square root of something we all know, right? To make life easy for ourselves. And the square root of 9 is 3. So that kind of works, so we know, right? So it brings out the square root of a number for us, and then of course, raise a number to the power. So again, let's start with something we all know. Double to the power. Okay, so that takes it to the power of 9, or 3 squared is 9. Let's see, 3 to the power 27. Probably that will return something silly. Yep, 3 to the power 27 was 3 to the power 3. And that works for us because 3 to the power 3 is 27 for us. So again, I won't do, and at some point, I will share this bit of code